fellow nerds. In today's video, we are going to continue with motion, and we are going to look at the question right here, which reads: a tortoise can run with a speed of 0.10 meters per second, and a hare can run 20 times as fast. In a race, they both start at the same time, but the hare stops to rest for 2 minutes, and the tortoise wins by a share of 20 centimeters. How long does the race take? Okay, so here we know there are two creatures that we are looking at, right? The tortoise and the hare, right? Okay, so how long does the race take? How long does the race take? All right, the race was supposed to be run to the finish line, right? Okay, and the tortoise reached the finish line because it is the one that actually did what? That actually won. All right. So what have we been given? Speed. We've talked about what speed is and its formula, right? So speed is equal to path traveled or distance traveled over time taken. Okay, to cover that distance traveled, or rather that path. So for the tortoise, its speed 0.10 meters per second. Its distance, right? We know the tortoise has traveled a certain distance to the finish line, right? The difference with the hare and the tortoise, because it only wins by a share, which means the tortoise was ahead of the hare by 20 centimeters, right? Which means it was at a distance at a distance x, where the tortoise and the hare were going to be at par. However, the tortoise added a 20 centimeter distance ahead. Now 20 centimeters distance, we're talking about meters per second, so we can convert this one, right? So we know 20 centimeters is about what? Okay, we did conversions in the previous video. So 20 centimeters, we have 1 meter over 100 centimeters. You can cancel out the centimeter. Cancel out the centimeter, we have 20 divided by 100. Okay, that gives us 0.2 meters. Okay, so 0.2 meters was the distance the tortoise was ahead by. Okay, so the time it took, all right, the time it took, that is the time it took. Okay, all right, so this time is the time it took for the whole trip, right? Because the tortoise reached the final point, the finishing line, right? Okay, so from here to here there is a time period for the same distance, for the same trip, right? And both the tortoise and the hare did travel in the same route, use the same route, which means the time constant would be the same, right? You will get the sense when we get to the hare and see what I am trying to talk about. Okay, so the time constant is the same because A to B was the same route that both the hare and the tortoise used. Okay, so basically this is our equation for the tortoise. All right, so this is equation 1. Okay, all right, so equation 2, we'll look at the hare's equation. Right, again, the hare speed is equal to distance over time. Okay, speed for the hare is said to be what? It's said to be 20 times that of the tortoise, right? 20 times that of the tortoise is the speed, right? The distance is just x, right? Because x was the distance that the hare was at. Then 0.2 meters ahead was the tortoise, right? So x was typically where the hare was. Okay, so time. Now the time for the hare, the time that the hare used to reach that distance x was the typical variable time. This time I was talking about because they had traveled the same route. the time constant, the time variable will be the same, all right? However, now the time variable for the distance is the same. The time the hare used to travel is different from the time the tortoise used it to travel because they were traveling at different speeds, okay? All right, so the time for the hare is equal to the constant time for the whole trip, right? For the whole trip, because the route is the same. This is a variable I was talking about, which is the same as that of the tortoise, okay? However, the time for the hare is different from that of the tortoise. So this is a typical variable time for the route that they both used, minus 120 seconds, right? 120 seconds. Okay, 120 seconds because this is like 2 minutes, right? The hair stops to rest for 2 minutes. And if the hair stopped to rest for 2 minutes, which means in the typical variable time, the 2 minutes, since we are dealing with seconds here, so 2 minutes multiplied by 1 minute over 60 seconds, right? This will give you what? So uh, oh, sorry, sorry, so this is minutes, so 60 seconds should be on top, then you have a minute down here, right? Because the instance is you have to cancel out that and that, which should give you what? 120 seconds, which is the 120 seconds there, right? So this time was the time that the hare used to rest, and in this time it did not travel any distance, which means it will not participate in the typical time for the hare, right? Because it didn't travel in the 120 seconds, right? Because the time we place here is the time that it took to travel the path length. And so the path the hare took did not include a 120 seconds of travel, because in 120 seconds the hare was doing what? Was resting. So basically this is your time for the hare, right? So I get back to the equation for the hare. You have speed is equal to distance over time. Speed is 20 times that of the tortoise, so we'll say 20 multiplied by 0.10. Okay, so you have 2 meters per second is equal to the distance traveled is x, the time is t minus 120 seconds. All right, this is equation 2. All right, so let's place the two equations. Okay, let's place the two equations and see how best we can use them. All right, 0.1. Okay, so our first equation is 0.10 is equal to x plus 0.2 over time, and 2 meters per second x over t minus 120 seconds. This is meters per second. Okay, so this is equation 1. This is equation 2. Okay, now we can now solve this simultaneously. Why? Because we have constant variables, right? We have constant variables, and so if you have constant variables in 2-3 equations, you can use simultaneous equation. All right, so we can just use which one is easier, whatever really you want. You can make either subject to the formula and replace in either equations. All right, so we all right, but this one was for the what? This is for the tortoise, this is for the hare. However, we are looking at how long it took the whole trip, right? The whole trip was from start to finish, right? The only creature that had reached the finish line was a tortoise. So we will prioritize equation 1 as our equation that we'll use. All right. But since the variables are the same, they would still give you the same answer. But again, you can use any. All right. But let's prioritize the tortoise because it won. I mean, come on. Winners, you know. Okay. So okay, so what are we looking for? We are looking for how long. How long is a time, right? How long is what? How long is time? Okay. So we are going to say 0.10 So here we can cross. So you'll have t there is equal to x plus 0.2. Okay, right? Then you'll have x is equal to, so we can also cross there, x is equal to 2 t minus 120 seconds. All right. Okay. Now, again, we are finding time, right? So we are trying to let t be the remaining variable in the equation we are going to use, right? Okay. And like I said, you can use either, but I have just chosen to prioritize equation 1 because it's a tortoise. Okay, so, but it doesn't really matter, you know. All right, so let's replace y there's x into the equation on top. So we'll have that. Okay, we can just solve this one. So you have 2t, that should give you 240 seconds, right? Okay, so you have, you can put those in brackets. 240 seconds, that is plus 0.2. Okay, so 0.10 is equal to, okay, since the sign is after the bracket, you can just open the bracket. This is just mathematics, right? Okay, so now the signs would have cancelled each other to this was in meters, right? So it's in meters, but you can verify on the standard units, they would have cancelled out, right? Or we can prove that, we can prove that, right? But since we have variables in with, okay, they would probably just take time, but the signs would have cancelled out to for this one to actually match the seconds. Okay, so the s, so this can actually work out as numbers. Okay, so we have 0.1 is equal to 210. So 210, so we can say negative 240 plus 0.2, that should give you negative 239.8. Change side, change sign, change side, change sign. So you'll have 239.8 is equal to minus 0.12. You can whatever bring this outside, it will still be the same. All right, so 2 minus 0.10, that will be 1.9t is equal to 239.8 over 1.9 over 1.9. So t is going to be 239.8 divided by 1.9, that is going to give you 126 point. Again, three significant figures we said last time. If you are not given exactly to what limit you should reach, you can just stick to three significant figures. Okay, so this is our time variable. This is our time, and so we know this is the time that the tortoise took, right? And if this is the time the tortoise took, this means this is the time the journey took, because the tortoise had reached the final line. Okay, had reached the final point. All right, so this is about the time. All right, so what is the second question? What is the length of the race? The length of the race. Again, the tortoise is the creature that reached the end of the race. So we are going to get back to the equation for the tortoise. All right, which is 0.10 is equal to x plus 0.2 over what? Over time, right? Okay, now this on top, this whole thing is the distance for the tortoise, right? The path traveled for the tortoise. Okay, so we are going to say d is equal to t multiplied by 0.1 seconds, or 0.1 meters per second, right? Because that is speed. So dt is equal to, if we're saying make x plus 0.2 be that, right? So t is going to be 126 seconds, 0.1 meters second. Signs are cancelling out, like I said earlier. All right, so 126 multiplied by 0.10, that will give you 12.6, right? 12.6. This is going to be your distance. This is going to be meters, right? So this is going to be the distance for the whole trip, because like we said, this on top is supposed to signal the distance for the what? For the tortoise, right? Okay, the x was a distance the hare reached, but we are not entirely concerned with the distance the hare reached, right? We're only concerned about the distance the whole trip took, and that is the distance that the tortoise took, which is 12.6 meters. Okay, all right, so this is the distance it took, because this is the distance that the tortoise traveled, and since the tortoise is the creature that reached the finish line, then which means this is the distance the whole trip had to take. Okay, so basically this is what we do on this question. This is how we go about it. However, you can use different equations along the course of solving it. You'd put it in a different significant figure, but at the end of it, all these values should be similar, right? You should be in a certain range depending on the significant figures that you've used and the equation that you used and stuff like that, right? Because yeah, basically that's about it. Well, I hope we have learned something. I hope the video was helpful, and if so, do share so we can all learn together, right? Okay, well, we'll meet later then. See you in the next video. Thank you.